When it comes to asteroid impact on Earth, it's not a question of if, it's a question of when.
66 million years ago, an asteroid crashed to Earth in the Yucatan Peninsula in Mexico. Debris from the explosion severely altered the climate and led to the extinction of around 75% of species, including the dinosaurs. A new study by the Southwest Research Institute in Texas suggests the rock came from the outer half of the asteroid belt in our own solar system. And it could happen again, which is why NASA is putting a plan into action. I'm here at Vandenberg Space Force Base off the coast of Southern California to witness something I last saw in a blockbuster movie. Scientists are getting ready to launch a spacecraft straight into an asteroid in hopes of changing its course. It's called the Double Asteroid Redirection Test mission, or DART. Carried on a SpaceX Falcon 9 rocket, the spacecraft, which is the size of a golf cart, will hopefully carry out the first demonstration of what's known as the kinetic impactor technique to change an asteroid's orbit. This sounds like something out of a movie, but is it?
It is, right? Frankly, some of these missions that we do, they feel like science fiction the first time you think about this. This is no exception. It is part of a movie, but it's something that we want to make reality right now.
The destination is more than 475 million kilometers away. Once in space, DART will separate from the rocket and use roll-out solar arrays that provide the solar power needed for its electric propulsion system. When you're looking at this launch, what you're worried about and what you're thinking?
So there's the increasing amount of objects in space. So as launch is cheaper, the domain itself is becoming even more congested. So the amount of objects that are up there, just in the last year and a half, that's doubled the amount of active satellites in the space domain. So on orders of right now, there's about 5,000 satellites up there. And as I mentioned, we're tracking more than 37,000 pieces of man-made objects in the space domain. So as launches happen, we need to make sure that we're screening adequately, so it just becomes more and more complicated as more objects actually get up there.
Once it's navigated the satellites and debris, DART will travel towards the asteroid Didymos, which is approximately 780 meters across. It has a secondary body or moonlet called Dimorphos, which is about the size of 1.5 football fields. That's the target, which DART will hit at 6.6 kilometers per second. The impact is estimated to change the moonlet's orbit by about 1%, which is no easy task.
It's very hard. We come with 15,000 miles per hour to a body we've never seen. And it's actually two bodies, so we're going to have to find the first one, which I'm sure that one will be easy, but then steer to the second one, which is much smaller, and hit it ideally as close to center as possible. So that will all have to be autonomous. Light is far too slow to joystick that. And so that's a complex problem. It's something that's really hard, and we're going to do it.
NASA's go for launch. 10, 9.
From this vantage point, we're about 5 kilometers away from the launch site. The countdown is going. Counting down now. We're about to launch.
1, 0. Ignition. Liftoff. The Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission. Vehicles pitching downrange.
It will take around 10 months before the DART spacecraft has the chance to encounter Dimorphos. The impact will occur when the asteroids are 11 million kilometers from Earth. What's your thought about this mission? It's something out of a movie. What is your thought about what's going on?
So growing up in a small dairy farm, it's amazing that I have the ability to play a part in this in some aspect, and just the amount of advancements that mankind can do to do something like this, just to play a small part, is incredibly humbling and pretty impressive.
DART will be giving the asteroid a gentle nudge, and there will be little to no debris from impact. China is also working on a more ambitious plan, and the target is the asteroid Bennu, due to come within 7.5 million kilometers of Earth between the years 2175 and 2190. Close enough for NASA to flag it as potentially hazardous. The probability of a collision is only 1 in 1,750, but it's close enough to cause concern. Bennu is 492 meters across, about the same as the height of the Empire State Building. Traveling at just over 100,000 kilometers per hour, its impact would have an estimated kinetic energy of 1,200 megatons, the equivalent of 80,000 Hiroshima bombs. So Beijing's National Space Science Center has come up with a plan. They propose using huge rockets to deflect potentially world-ending asteroids like Bennu. China's Long March 5 heavy-lift launch vehicles could be adapted for the mission with some small modifications such as adding thrusters. Weighing 900 metric tons each, 23 of these rockets will need to push against the asteroid simultaneously in order to alter its course by 9,000 kilometers. This would be safer than more direct approaches, such as firing an atomic bomb at the asteroid, which could create a shower of potentially hazardous smaller objects. NASA has also previously suggested far more ambitious plans than DART to deal with the Bennu-sized asteroids. The Hypervelocity Asteroid Mitigation Mission for Emergency Response, or HAMMER, offers two options: several 9-meter-tall spacecraft to nudge the asteroid into a safer trajectory, and a precisely directed nuclear explosion. DART is more of a hit and deflect approach. It's also a fact-finding mission testing NASA's ability to be more proactive. It will be carrying the Didymos Reconnaissance and Asteroid Camera, or DRACO, a narrow-angle telescope that helps it navigate directly into the asteroid. It also has a small CubeSat that will separate 10 days before the crash and remain nearby to capture images of the impact. The asteroid is not a threat to Earth, but this mission is about future planetary defense.
At this moment in time, we do not know of a single body threatening the Earth in the next 100 years or so. It's also true that for sizes of, like, call it football stadiums or soccer stadiums, or 140 meters or higher, we have only observed about 40% of them. So we need to go observe them. It is true that the history of the Earth has had many of those impacts, some of them much more massive than that, including the one that, of course, wiped out the dinosaurs, which was 6 miles, 10 kilometers in diameter. When it comes to asteroid impact on Earth, it's not a question of if, it's a question of when.
It's all finished. Oh, don't worry. We've got loads more cool science and tech stories from Razor. All you need to do is like, comment and subscribe, and hit the bell button below for notifications. See you next time.